Hey everyone! Welcome to this little adventure where we're tackling a seriously big question. Just how massive is our solar system? Spoiler alert, it's way bigger than you'd think. Stick with me and I'll break it down for you in a way that actually makes sense. I'm Mini Hexa, and today, we're diving into the solar system. Look at this place. It's giving big middle-of-nowhere vibes. Not bad for a solar system overview. But wait, this is way too empty to explain the size of our cosmic backyard. We need something more relatable. A city would be perfect, so let's get closer to it. What's a better scale reference than a bunch of skyscrapers and busy streets, right? While we're cruising here are some fun facts about the solar system. The Sun makes up a whopping 99.86% of the solar system's total mass. It's basically the heavyweight champion of our corner of the universe, while everything else, planets, moons, comets, and asteroids, only accounts for the remaining 0.14%. Earth is tiny. If we scaled the Sun down to the size of a basketball, about 22 centimeters in diameter, Earth would be smaller than a peppercorn. And the distance between the two? A staggering 25 meters. That's a lot of empty space. The giant planets are really giant. Jupiter, the largest planet, has a diameter of about 139,820 kilometers, 86,881 miles. It's so massive it could fit around 1,300 Earths inside. Despite how movies depict it, the asteroid belt between Mars and Jupiter isn't crowded. The average distance between asteroids is hundreds of thousands of kilometers. Plenty of space to cruise through. Unimaginable comparisons. If you shrank the entire solar system to the size of a coin, the nearest star, Proxima Centauri, would still be about 270 kilometers, 168 miles, away. Well, here we are, on top of the world. Or well, at least on top of this building. Speaking of the world, let's start with our home, Earth. Here's the plan. To really understand the scale of the solar system, we're going to build a model. In this model, the Earth will be just 2 centimeters in diameter. A little blue marble, right? And here's the moon. It's teeny tiny, only 5.5 millimeters across. Think of it like a small bead. But here's the fun part. In our scale model, the moon orbits 1.2 meters away from Earth. That's about the length of a table. The space between Earth and the moon is so vast that you could line up every planet in the solar system, side by side, and still have room left over. Crazy, right? All right, now that we've got our Earth and moon in place, let's zoom out even more and bring in the star of the show, literally. Here's the Sun. And in our scale model, it's a whopping 2.2 meters in diameter. That's taller than me. Not that that's saying much. The Sun is the powerhouse of our solar system. Not only is it huge, but it's also ridiculously heavy. Get this, its mass is about 333,000 times that of Earth. If that sounds like a lot, it's because, well, it is. As I said before, it's responsible for 99.86% of the total mass of the entire solar system. Okay, let's break it down. Here's a little visual to help. I simulated 333,000 Earths that will come out of the Sun. See the white dots over there? Each of them represents the Earth. It's basically a pebble compared to the Sun's mountain of mass. Here we have a fully scaled down solar system. Let's take a quick tour of the inner planets, starting with the speedy little one closest to the Sun, Mercury, which orbits the Sun with a radius of 58 million kilometers. At this scale, it's 91 meters. Mercury, small, rocky, and baking hot during the day, but freezing cold at night. With a diameter of about 0.76 centimeters in this scale, it's not much bigger than a small marble. And fun fact, Mercury has the fastest orbit of any planet. It zips around the sun in just 88 Earth days. Next up, we've got Venus, which orbits the sun with a radius of 103 million kilometers. At this scale, it's 170 meters. She's Earth's twin in size, about 1.9 centimeters in our model. But don't be fooled. Venus is covered in thick clouds of toxic gas and has surface temperatures hot enough to melt lead. It's like the solar system's very own pressure cooker. Oh, and fun fact, Venus spins the opposite way to most planets and takes longer to rotate once on its axis than it does to complete its orbit. So, technically, a day on Venus, 243 of our days, is longer than a year, which is 225 of our days. Wild, right? Now we've got the Earth. Our little blue marble measures 2 centimeters in diameter in this model, and it's the only planet we know of that supports life. It orbits the sun with a radius of 150 million kilometers. At this scale, it's 236 meters. Here we have Mars, the red planet. At 1.1 centimeters in diameter here, it's smaller than Earth, but still manages to capture our imagination. Why? Well, it's the most likely candidate for future human exploration. Plus, Mars is home to Olympus Mons, the tallest volcano in the solar system, 3 times the height of Mount Everest. Pretty epic for a tiny planet. It orbits the sun with a radius of 228 million kilometers. At this scale, it's 360 meters. Here's the big boss, Jupiter. In our model, it orbits the sun with a radius of 778 million kilometers. At this scale, it's 1,225 meters, and its diameter is about 22 centimeters. That's like a good-sized beach ball, making it the largest planet by far. And check this out. Jupiter has at least 79 known moons, including the largest one in the solar system, Ganymede. It's bigger than Mercury. And here's something wild. That storm you see, the Great Red Spot, it's been raging for centuries. At its peak, it could fit 3 Earths inside it. Now that's some serious weather. Next up, we have Saturn, the jewel of the solar system. In our scale, it orbits the sun with a radius of 1,430 million kilometers. At this scale, it's 2,268 meters. Its diameter is about 18 centimeters, but those stunning rings steal the spotlight. They're made of chunks of ice and rock, some as small as a pebble and others as big as a house. Here's a cool fact. If you could find a bathtub big enough, Saturn would actually float in it. That's because it's mostly made of gas and has an incredibly low density. Now we're getting chilly with Uranus. In our model, it's about 7.6 centimeters in diameter, roughly the size of a grapefruit. It orbits the sun with a radius of 2,870 million kilometers. At this scale, it's 4,725 meters. But what really makes Uranus stand out is its extreme tilt. It rolls around the sun like a ball on its side. Scientists think a massive collision in its early history knocked it over. And while it looks calm and serene, Uranus has some of the coldest temperatures in the solar system, dropping as low as -224 degrees Celsius. Better pack a really warm coat if you're planning a visit. Finally, we've reached Neptune, the solar system's icy giant. At 7.3 centimeters in diameter in our model, it's slightly smaller than Uranus. This planet orbits the sun with a radius of 4,500 million kilometers. At this scale, it's 7,087 meters. But don't let its calm appearance fool you. Neptune has some of the strongest winds in the solar system, reaching speeds of over 2,000 kilometers per hour. Oh, and fun fact, Neptune is so far away that it takes sunlight over 4 hours to reach it. That's some serious long-distance relationship with the sun. And hey, if you're a fan of learning cool stuff in a fun way, hit that subscribe button and join me. It's a small gesture that goes a long way in helping me make more of these galactic journeys.